Hello Urates and welcome back to mathematics. In today's video we're continuing with our topic of measurement and we're looking at the final bit of Pythagoras' theorem for now. What we're doing in this lesson is we're using Pythagoras' theorem once again to help us find the length of missing sides. But this time, instead of it being the hypotenuse, which we looked at in the last video, we're going to be looking at how to find the length of a shorter side. So in today's lesson, we're going to be applying Pythagoras' theorem to help us find missing sides, and we want to be able to recall Pythagoras' theorem and rearrange for the shorter sides, and also apply Pythagoras' theorem to find the length of shorter sides. So let's get into it. So over the last couple of lessons, we've been working with Pythagoras' theorem. And Pythagoras' theorem is a relationship between all three sides of a right-angled triangle. The relationship is this one here. A squared plus b squared is equal to c squared. When I square the two shorter sides, a and b, and I add them together, it's going to give me the square of the longer side, the hypotenuse, c squared. And so if you remember from the last lesson, we were actually using this to help us find the length of the hypotenuse, c squared, when we went and we said c is equal to the square root of a squared plus b squared. And so we were able to actually find the lengths of our missing hypotenuses. This time, instead, we want to see if we can rearrange this equation to help us find the missing length of one of our shorter sides. So let's say A, for example. Now, I'm going to be rearranging this for A, but no matter what way you look at it, A and B, you can use this exact same formula for A or B. Okay, so let's actually get into rearranging this. Now, what I want to do is I want to write this formula, but make A sit by itself. So here, what I'm going to do is I'm first going to move this plus B over to the other side of my equation. And the way I do this is I'm going to subtract it. I'm going to subtract B from the other side. So here I'm going to write this as A squared is equal to C squared minus b squared. So what I've done is I've moved the b squared to the other side, but because we moved it to the other side, that plus sign now becomes a minus. And just like we did last lesson, what we need to do if we want to get rid of the square symbol is we need to take the square root. So here I get rid of the square symbol and I'm going to write this as is a is equal to the square root of c squared minus b squared. So here what we want to do, if we want to find the length of the longer side, instead of adding the two square terms together and taking the square root, what we want to actually do is to subtract it. And this is the formula we're going to be using for today's lesson. So if we want to find the length of a shorter side, I scrolled down a little bit too far. I'm going to copy this. If we want to find the length of a shorter side, what we want to do, just like we do in with regular Pythagoras, with Pythagoras' theorem when we're looking to find the length of a longer side, what we want to do is we want to identify the two lengths of the given sides here. So we want to identify which one is the hypotenuse and which one is our shorter side. Then what we're going to do is we're going to square both the sides. So identify, then we're going to square both the side lengths. So if you have a look here in my formula, I still got c squared, so I'm squaring the hypotenuse. I've got b squared, I'm squaring the shorter side. Then this time, instead of adding, we're going to be subtracting two side lengths together. And then from there, we're going to take the square root of the result, just like we did in the last lesson. So let's have a go at applying this in a question. So here, what we want to do is we want to find the length of the missing side in this right angle triangle. So if we have a look at this diagram, we've got 5. That is our hypotenuse. If you have a look at my right angle triangle, that's the side directly opposite my right angle. So this one here is going to be the value of C. And we've also got another side. We've got 4. And so that is going to be one of my shorter sides. And I've got this missing side over here, A. I don't know what A is. So I'm going to use Pythagoras' theorem to help me solve for this. What I'm going to do is I'm first going to just rewrite Pythagoras' theorem. So this time I'm going to write it as a squared plus b squared is equal to c squared. And what we did when we rearranged this was this became a is equal to the square root of c squared minus b squared. So that was when we rearranged it above. Now that I've done this, all I need to do is just replace C and B with the values for them. So here, just be really careful. C has to be the hypotenuse. So in this question, C is actually going to be this hypotenuse of 5. And so this is going to be 5 squared minus B is the shorter side. So the other short side I have is 4. So this is going to be 4 squared. And so I can chuck this straight in the calculator like I did last lesson. So here I'm going to put this straight in my calculator. So I've got square root 5 squared minus 4 squared, and that will give me 3. And so my length A is actually going to be 3. Okay, so here what we did was we wrote the Pythagoras Theorem again, we rearranged it for A, and what we needed to do was we need to identify our two sides, so the hypotenuse and the other short side. Then we squared it, so if you have a look inside my square root, I've squared both of them. And then this time, instead of adding them together, I'm going to subtract the 2. I'm going to subtract the 2. And then final bit is then we take the square root and then we get our answer here. So that's how we can use Pythagoras' theorem to help us find the shorter side. Let's have a look at another example. Now in this next example, we're going to be applying it to a worded problem. Applying Pythagoras to find the shorter length. If you have a look here, a 10-meter steel brace holds up a concrete wall. The bottom of the brace is 5 meters away from the base of the wall. Find the height of the concrete wall corrected 2 decimal places. So if you have a look here, we've actually got another right angle triangle, just like we had a look in that example from last lesson. Here we've got this right angle triangle. Let me draw it in yellow. That looks like this. And you have a look at the sides I have. Well, I've got this 5 meter side, which is one of my short lengths. And I've also got this 10 meters, which is opposite my right angle. This 10 meters is my hypotenuse. And so what I need to do, if I want to find the height of the wall, that's a shorter side. So I need to apply the Pythagoras theorem like we were doing in this lesson. So let's actually go through the steps of solving this. First of all, I'm just going to call the length or height of the wall. We want to find the height of the concrete wall. Let's just call this h for height. So I'm going to say that, so first of all, we're going to write Pythagoras' theorem. A squared plus b squared is equal to c squared. I'm going to rearrange it. And so here we're going to get a is equal to the square root of c squared minus b squared. Now that I've done that, I'm going to replace a, b, and c with the relevant lengths in this question. So first of all, a is the side that I'm missing. In this case, I've named it h, so I'm just going to replace it with h. So h is going to be equal to the square root of c is my hypotenuse. So in this triangle, the hypotenuse is the longer side. It's at 10 meters. So I'm going to have 10 squared minus b, which is my other short side, which is at 5. So 10 squared minus 5 squared. And I can put this straight into my calculator. I'm going to get 10 squared minus 5 squared is equal to 8.660. We want this to 2 decimal places. So this is just going to be 8.66 meters. And that's how we can use Pythagoras' theorem to help us find the length of a shorter side. Okay, so that's it for today's lesson. Let's just do a quick recap of what we looked at in today's lesson. In today's lesson, we looked at finding the length of a shorter side in a right angle triangle. When we need to find the length of one of the shorter sides in a right angle triangle, unlike last lesson when we added the two squared and then added 2 side lengths together, what we need to do is we need to subtract. And so here, when we rearrange Pythagoras' theorem, we noticed that instead of adding, we needed to subtract the 2 sides. So here, just like we did last lesson, what we want to do is we want to identify the 2 side lengths given, and in particular, we want to notice which one is our hypotenuse. Then we want to square the 2 sides that we have, and then subtract the 2. And then the final bit, like we did last lesson, we take the square root to help us find the missing side. And so here we went through a couple of examples where we need to apply this particular formula to help me find the length of a missing side. So that's it for today's lesson, Year 9. It's a little bit of a shorter lesson, so hopefully you'll have a chance to have a go at the questions. If you have any questions, feel free to email me or let me know. I'm more than happy to try and answer them for you. But until next lesson, Year 9s, I hope you guys are staying safe wherever you are, and I'll see you in the next video. Bye!